Some scientists say Titan, not Mars, and today I'll ask a planetary scientist that question. This is About Space Today's special report, Beyond the Moon to Mars. I'm David Denault. If you've been listening to our podcast, you've heard Elon Musk talk about his plan to colonize the Martian planet. But some scientists, like Amanda Hendricks, say we should be looking elsewhere to Titan, a moon slightly bigger than our own that orbits Saturn. Amanda Hendricks explains her plan for a colony on Titan rather than Mars.
I'm Amanda Hendricks. I'm a senior scientist with Planetary Science Institute. First of all, I don't want to be too negative about Mars. I like Mars. I do think we should go there. Humans should go there to visit and check it out and do science. I just don't think it's a good place for living for long term. And the main reason is because of the radiation problem. And Mars offers no natural protection against the galactic cosmic rays. It has a thin atmosphere and no magnetosphere. So humans who intend to spend any long period of time on Mars are probably going to have to live underground or in some sort of devices that can shield them from the galactic cosmic rays. Titan, on the other hand, has got this natural shielding device, which is its nice thick atmosphere, because it's such a more appropriate environment for humans. Titan is really unique because it's a moon and it has a solid surface. It's mostly an icy moon, but it has this thick atmosphere. And it's unique because there's no other moon in the solar system that has such an atmosphere. The atmosphere is mostly nitrogen. It's about 1 to 2% methane. So one thing to point out is there's no oxygen in it. And so humans living on Titan would need to make oxygen to breathe. Shouldn't be a big problem because there's plenty of H2O frozen on the surface and in the subsurface. So humans could derive oxygen to breathe without a big problem. Perhaps a good option might be for them to try out a very temporary short-term colony of humans on Mars and use that as a stepping stone to Titan. Use it kind of as a practice run. I think that would be a great idea. But somebody like Elon Musk has got the resources and the smarts to be able to work on Titan and to make a colony there happen and to make the propulsion system happen. And so I think he should be thinking about Titan.
Joining me once again is planetary scientist Dr. Ryan Ogliore of the University of Central Florida. And welcome back, and thanks for taking time to discuss the moon, Titan. Ryan, how far is Saturn from Earth, and how long could it take to get there?
Saturn's very far away. So the Earth orbits the sun at a distance of 1 AU. It's called an astronomical unit by definition. And so Saturn's between 9 and 10 AU. So it's more than 9 times farther from the sun than the Earth is. We sent a couple spacecraft there, and we are sending one in a couple years. We sent Cassini there. It was dedicated to explore Saturn and its moons. It took 6.5 or 7 years to get there, and that's about how long it will take the next spacecraft to get there, called Dragonfly. So that's via some flybys of the Earth and Venus. You can never really go straight there with our current rocket technology that we use to launch these space missions. So they get little kicks from the inner planets and make it there in several years. So it's very far away. So if it's, it's 9 to 10 AU, that means the sunlight is about 1% of what it is here on Earth. So it's very dark and cold out there.
Now, this moon that they talk about, Titan, why are we looking at Titan? Is it habitable?
Titan is amazing. So it's, for a long time, we've looked at Titan through telescopes, and it's looked hazy. I mean, you can see this with a nice telescope at an observatory, at like our observatory at UCF. So it looks hazy. So we know it had clouds, and it's been this moon of it's been intriguing, and it's been a very high interest since back to the Voyager days. And Voyager 1 visited Titan, and it sacrificed the outer planets Uranus and Neptune to visit Titan. Voyager 2 went on to visit the ice giants as well. But that's how important of a target it was. It changed the whole trajectory of Voyager 1. It had to go out of the plane of the solar system to investigate this very intriguing moon. So we knew for a long time it has clouds. We sent Cassini there, which dropped the Huygens probe down to the surface of Titan, and what we saw was amazing. It was a world that looked like Earth, in that it had clouds, it had mountains, it had rivers and lakes. The lakes and rivers are made of methane, not water. Dunes and erosion. And so when you look at like the kind of, when I think about Earth, I think of clouds and mountains and rain and oceans and lakes and that kind of processes. And those processes are happening on Titan. The chemistry is different. The materials are different. It's very cold and icy. But in those ways, it's kind of this Earth-like world. Habitability wise, like I said, there's 1% of the sunlight reaching Titan as Earth. So it's very, very cold, like extremely cold.
Yeah.
That atmosphere has almost no oxygen in it. It's made almost entirely of nitrogen. That haze is from hydrocarbons. And so there's a lot of carbon chemistry happening on Titan. And when I say those words, it sounds like it's that's what gives rise to life, and it does. But probably not on Titan. It's probably, think of like the evolution of life from basic carbon chemistry to complex life forms. Titan got, maybe 1%, 2% of the way there. And so that's why we want to explore Titan, is see how far it got on that road of prebiotic chemistry. So it's a fascinating world. I love all these outer solar system moons. They're all so different. And Titan in particular has that Earth-like qualities to it. And the Huygens probe images are some of my favorite images in planetary science. They're so cool.
Now, we've heard Dr. Hendricks lay out good reasons to go to Titan, and you've been involved in NASA projects and plans to send unmanned spacecraft to Titan in the near future. I'd like to ask you, we're going to do a 3-part series, but I'd like to ask you to come back next week, and I want to talk about dragonfly.
Great. Thank you.
Thank you for joining us in our series and extending one more week and learning more about dragonfly and a great mission ahead for NASA. Thank you for your participation.
Great. Thank you.
And continue to check out our Facebook page at aboutspace.today for launches, landings, and special reports. And if you like our reports, click like, follow, and hit that subscribe button. And to all our listeners around the globe and here in the U.S., thanks for taking time from your home or from where you work to listen today. I'm David Denault.